Prime numbers are the most important numbers in mathematics. They are the building blocks, the fundamental atoms from which all other numbers are constructed. Think of them like the elements in chemistry. Hydrogen and oxygen combine to make water. In the same way, prime numbers combine to make every other whole number. A prime number is a number greater than one that can only be divided by itself and 1. The number 7 is a prime. You cannot divide it by 2, 3, 4, 5, or 6 without leaving a remainder. In contrast, the number 6 is not a prime. It can be built by multiplying 2 and 3, both of which are primes. This unique property makes primes the irreducible components of the numerical world. The sequence of primes starts simply enough: 2, 3, 5, 7, 11, 13, 17, 19. At first, they appear to be close together, but as you count higher, they become scarcer. The gaps between them grow larger and more unpredictable. This journey along the number line is like a walk through a strange, sparse forest where the trees suddenly appear without warning. The ancient Greek mathematician Euclid proved over 2,000 years ago that there are infinitely many of these primes. There is no last prime number. No matter how large a prime you find, there is always another one waiting to be discovered further down the line. This infinite nature is both beautiful and deeply perplexing for those who seek order. Understanding these numbers is not just an academic exercise. It is fundamental to our digital lives. Primes are the guardians of our secrets. When you buy something online or send a secure message, your information is protected by a lock made of very large prime numbers. The security of modern encryption relies on the fact that it is incredibly difficult to find the two large prime numbers that were multiplied together to create an even larger number. Your bank details are safe because mathematicians and computer scientists have exploited the elusive and chaotic nature of these special numbers. Without primes, the digital world as we know it would be impossible. This essential role in both pure mathematics and practical technology gives primes a dual identity. They are objects of pure, abstract beauty, studied for their intrinsic properties and the patterns they might hold. At the same time, they are powerful tools that underpin the security of our modern civilization. They are the most basic and yet the most mysterious of all numbers. For centuries, mathematicians have been on a quest, not just to find new primes, but to understand the very law that governs their distribution. They want to hear the music that these numbers play, to find the rhythm hidden within their apparent randomness. This search for a pattern is one of the greatest stories in the history of human thought. The desire to find a pattern in the primes is as old as mathematics itself.